multiple IPAM and SRv6 L3VPN using Cilium Enterprise Edition CNI. As of today, as of Cilium OSS and Enterprise 1.17, multiple IPAM is supported in Cilium OSS. SRv6 L3VPN feature is supported in Cilium Enterprise Edition. However, the combination of both is not supported. This recording and the slides are based on the prototype that I've made on the Cilium Enterprise code, and that's not part of any official roadmap. It's art of the possible approach from the development perspective. Feel free to reach out if you're interested in productization of this feature. You can keep your default pod CIDR for non-VRF workloads. You can dedicate an IP pool for per tenant VRF workloads. The dedicated LB pool for per tenant services is already supported. So the only thing that is provided by this extension prototype is the fact that you can have dedicated IP pool per tenant VRF workloads. So as a benefits, you can have an IP address mapped directly to VRF or tenant, which should improve operations and troubleshooting. Keep in mind that multi-pool does not support overlapping IP subnets. So while you can dedicate IP pool for different tenant or VRF, these pools have still to be non-overlapping. In the demo, I will use this topology. It's also part of the different published demonstrations on this channel. Before creating the IP pool and deploying a pod as a part of the VRF, let's have a quick overview of the state of the cluster, BGP, and services. So we have a 4-node cluster. Oops, I will make it available. So we have 4-node cluster, 1 control plane and 3 worker nodes. SRv6 responder is on the control plane node. From the BGP perspective, the sessions is configured already. Check different videos on how it can be done. So we have the BGP sessions established on every node towards the top of the rack for V6 and route reflector for MPLS V4. We have the locator pool defined, and then from this locator, every node from this pool, every node will get its own locator. And lastly, we have 2 VRFs, red and green. The red one is enabled, and it has no pod currently labeled, annotated to be part of this VRF. So if we go for example, to eBPF maps, we will see the outcome is that we have SRv6 policy map populated based on the BGP advertisements. We have the SRv6 seed map populated based on the locator allocation, and we have no SRv6 map entries because there is no pod currently deployed as a part of any VRF, either red or green. Let's also check the PE route table state before proceeding. PE11 is the top left device to which red CE is connected to. If we check the BGP VRF1 table, we at this stage see the pod CIDR advertised over BGP via the route reflector. So that's as to setting up the scene. Right now, let's go to the target demonstration as a secondary pool, and then creating a deployment in that pool, which will be the part of the VRF. So let's create the pool first. The pool is created, and since there is no pool client yet, it's only created from the Cilium operator perspective. It's not associated with any worker node. So if we go to the state of the PE device, we will not see it advertised yet. It's defined on the cluster level, but it's not consumed. There is no subnet is allocated to any node. That's why there is no BGP activity yet at this stage. So going back to the pod IP pool page, let's create an application, a pod that will get an IP address from pool 66 and will be part of the VRF. Checking on the CRD YAML level. What's so special about this definition is that we have the annotation for the pool as well as the label for the VRF. The pod request has been sent to Kubernetes cluster. The Kubernetes scheduler will select the target node, kind worker 3 in this case. That node will request a subnet from pool 66. That subnet will be given or leased by an operator to an agent. So we have 10.66.66/28 allocated from /24 on kind worker number 3. And then the pod will be allocated an IP address from that pool on node kind worker 3. That pool has been already allocated to kind worker 3, so we can expect some activity or some state change on BGP. So let's check that. We have it, 10.66.66/28. It's actually advertised by node :2, 6663, which is kind worker number 3. So while we have all the default pod CIDRs advertised, we also have an extra pod, an extra subnet advertised by the node on which this subnet is actually allocated, which is in that case kind worker 3 node. If we would check the eBPF maps, we will see that this new IP address that has IP address from pool 66 and is running on pod on node number 3 is also populated in a VRF map because it was labeled as a member of a VRF number 1. And this way we have achieved the end-to-end connectivity. We have the pod allocated with the non-default pool subnet. It's labeled with the VRF. That subnet is then BGP advertised. The network the routing is converged. We have end-to-end connectivity in the red VRF between the classic L3VPN sites as well as a pod deployed in Kubernetes cluster.